바꿨나 보지. 아 맞아 그래.
내가 전에 쓰던 지우개가 별로라서 이번에 바꿔가는.
너무 강해.
내 냄새? 땀 냄새?
아니 그냥 뭔 냄새인가?
아까 전에 샤워하고 아까 전에 머리 감고 왔어.
역시 안 켰지?
너가 하는 거 아니야 이걸로? 아니 바로 못해.
마커가
여기 갖다
겨울인데?
하찮은 녹아줘.
그럴 수도 있어. 우리 원래 시끄러웠어. 변함없지.
땡. 진짜.
여기 남자는 왜 안 와? 너네 같이 안 해? 남자 이제.
내가 뭔가 떨어졌어.
원래 삐뚤어졌단다. 변함없이.
된거 같아. 아 살짝.
달랐으면
어쩔 수 없어.
배고프다. 아,
뭐 나가고 있어 이거?
아 나가.
아 말을 해주지 그러면은.
민재는 아직 안 왔어?
응.
민재도 있구나.
네?
민재
안녕하세요. 구독과 좋아요.
주문이 거야.
이윤재랑 뭔 얘기를 많이 해?
민재 어디 있을 거야?
저희 집 못 가요.
민재 나 민재도 집에 가는 줄 알았어.
진짜 너무 하시는 거 아니야?
너 집에 안 갔어?
집에 왜 가죠?
왜 가? 왜 안 가?
왜 그래?
그래도 돼?
아니 저 계속 교회 있잖아요.
오늘 촬영이 있어가지고.
맞아요. 저희 테이프 교회에서 하잖아요.
어. 아 이것도 같이 들어? 아 그래? 난 너 집에 가는 줄 알고 네 걸 안 사왔지. 줄이 거 먹어도 돼. 그냥 안 먹으면 됐어 아까. 빨리 먹어. 난 당연히 너 집에 가는 줄 알았어.
그니까 줄지에 사라져.
아니 줄이 안 먹는다고 그랬어 아까.
그랬어요? 인천은 뺏어 먹어.
아니 저번 주도 그랬어 은혜야 미채야?
아니 저번 주는 양육 기간이어가지고. 기말고사가 지금 13회 남았어.
중간고사 벌써 갔냐?
아 기말이래 중간고사.
민재를 어떻게 알았대?
몰라요.
지각이에요 지각.
지각 다음에 멘트.
호랑이가 대만
집에
온다는데.
안 돼.
지각 안 해.
메이치를 안 해.
근데 이거 야채가 안 보이는데. 아 있네.
민재가 방송국 분위기 알았는데?
응?
안 왔어요?
이거 안 할게요.
중국 있는데
있어요. 중국 오라고 그러셨어요?
아니요.
아니
맞아요.
응?
아.
난 레이첼 아니 레이첼.
아니요.
민재가 여기 사는지도 몰라 그래.
아.
민재가 오늘 안 사네.
괜찮아요.
이거 머리 감기만.
머리 이상하게 봐. 그냥 이거 지금 먹지 말고.
지금 먹자.
예제 선생님 그럼 이제 마치고.
마치고 먹으면.
그랬었어? 나중에 언니랑 같이 먹어. 언니야 너 하는지 몰랐다 이거. 가방에 잘 사.
나 잡고줘.
가방에 잘 사.
귀찮다.
민족에 키울 수 없나?
아 8시.
아
한 시간 하게?
다음은 좀 하나 가지고.
중국에서 그러면
그래 근데 됐어. 이런 것도 다. 2020. 나 몰랐어. 스커트 안 하고 아무것도 모르고.
지금 안 먹으면 나중에 중국 올 때 사먹을게.
중국 어디 가는 거?
레이지 끝내고
우리 8시간부터 먹는 거?
아, 그러니까 그 김밥 같은 거 해도 엄마 지금 풀 먹고
레이지 끝나고? 내일 8시 반에 끝났는데 우리 10분이 내려가는데?
8시 반? 근데 내가
8시 반에 끝났지?
8시 끝났는데 항상 8시 끝나고 우리 하고 뭐 하다가 하면
당연히 민채 집에 가는 줄 알고 집에 가는 줄 알았지.
어린이 거 독서토론 뭐 하는 거?
나 그거 1도 안 했어. 나 안 하려고. 안 할 거야. 그래 참. 쌤한테 먼저 얘기해 낼 거야.
나 점심 먹기 전에 올렸는데.
아니 근데 그거 어디 하는 거야? CS? 아 그거 쓸 건데.
그거 책이 전체로 CL이 뭐야?
CSA.
에세이 그거 그 유년 쓰기 한 거?
그거 나 쓸모
그거
뭐야 어차피.
책 전체 그러니까 우리 책 같은 거 많이 읽었잖아. 그걸 하나로 뚫는 주제를 하나 정해가지고 그래서 나 생존에 대해서 읽거든.
여기서 참 잘.
오.
오 무겁겠어요. 완전 2리터죠. 2리터 들고 다녀.
그거 하루에
야 이만큼 먹어야 된다니까?
하루에 4개? 3개?
4개? 와, 야, 이만큼 안 먹는데. 500ml 화장실에 먹고 가는
대박이다.
하루에 하나가 원래 권장인데 이거.
3개는 진짜.
근데 좀
진짜 1시간에 한 번씩.
3개.
와. 아,
6ml
있어.
3개 있어. 와우.
대박.
학교 문제 있어요.
물어봐, 민채야. 빨리. 그냥 민채야.
질문 있으면 물어봐요. 아니면
있어, 근데 저기.
영어 수업.
I want to cube equation. Cube equation.
Cubed? Oh. It's basically the same.
여기 센수학 있는데.
야, equation이 뭔데? So cube is just,
아,
what does cube look
6항이
like?
2학년. 6항이야.
헐.
6항이
What
2학기.
does cube look like?
큐트.
Why?
I don't know.
Okay, well, let's think about it. Let's take the simplest one. How do we make a graph? What do we do? How do we make a graph?
We don't learn the graph. We just equation.
Oh no, you don't need it. No, graph is more important. First, you need to know what's happening, right? Because equation is just doesn't mean anything. When you just give you an equation, how are you supposed to know what it looks like or what it means?
저 배워 학교에서 우리?
아니 그 그래프는 안 돼.
기본 아니야?
그냥
응?
3차 방정 식으로
저 쓰는 거
아, 저
물어본
정도가
거.
기본이래. 와, 존경.
Okay. So what should we do to make a graph? Okay, what's your general approach? What should always be your approach?
0,0.
Yeah, plug in some points. Okay, try x equals 0. Then maybe x equals minus 1. X equals 1. You know, see what's happening. Okay? And then you see, you plug this in, and then you get what y is. So x is 0,
0.
y equals 0. So we know that this point is in our graph.
Yes.
Okay, x equals minus 1.
Minus 1.
Alright, then what do I put in our graph?
Minus 1 minus.
We know this one's here.
Yeah.
Alright, what about x equals 1?
1.
Yeah. Alright. And then we have to see what's changing. So it's going to change quite a bit. Imagine that this keeps going. We got more here. Okay. So now let's try x equals 2. See what? Yeah. Ah, this is growing very fast. Right? So we've already we can kind of see, oh, well, that's going to grow very fast. Because what's the next one?
Minus
3 equals y equals.
3.
Yeah, so it's already going to be way up there. And that's how you get that it's a curve and not a line. Because it's growing faster than a line would, you know?
Yes.
Okay. Now, what about x equals minus 2?
Minus
So what do we get? We get a point down here. Ah, it's the same. Except it's negative because it's a negative number cubed. Okay, this is our graph. Y equals x cubed. You already have a picture. Okay? So in general, when they give you some stupid equation, just plug in values and see what it looks like. Because that's much easier to see what's going on. Okay? So then, you know, if I were to give you like y equals x cubed plus x squared plus x, what would it look like? Well, it's not, see, it looks worse, but actually it's not that bad. Because what can we do? Yeah, so what do we take first?
0.
Y equals 0. Alright, x equals 1.
3.
3.
Minus x equals minus 1.
Minus
1.
Ah, so yes, minus 1. You were right. I was being dumb. Alright, so yeah, minus 1. Alright. Then what if we have x equals 2?
14.
14.
Oh.
And what's going to happen as it keeps going up here? Because what's x equals 3 going to be? Is it going to be a lot bigger?
Yes.
Yes. Alright, so we're going to have something like this
Oh.
that grows even faster than the x cubed function. Okay? Alright, and then so what's going to happen now with the negatives? Alright, let's see what happens. X equals minus 2.
Minus 6.
Alright, yeah, so we got something like, let's put it here. Imagine that's minus 6. X equals minus 3.
Minus 21.
So, how is this one going to compare to the part on the positive side?
It is low.
It is, yeah, it's not as steep. This is a very steep slope. Very steep. Growing very fast.
Yes.
Since we have this is plus. This is big minus. Big minus. And this is little minus. So, it's all minus, right? It's going to keep getting more minus. But not as fast as this gets more plus. So it's going to look something more like that. Okay? So the key is to think about, okay, what's happening as, x gets more positive, x goes bigger and bigger and bigger, and then what's happening is x gets more negative, less and less and less. And then see how y looks. Okay? Cool. What about what if I were to make the x cubed the minus x cubed, and how would it look?
플러스
Y equals minus x cubed. What does that look like? Someone tell me what to draw here.
리버스
How so?
like that.
It's exactly the same, except that we have it like
오,
this.
DNA.
It's more like a spider.
파이널.
Okay, right? Because it's just reverse the values. Okay? Right, any more questions from school? Does this all make sense? No question?
쿼드리 펑션 쿼드리 펑션은 I.
Ah, we did that last time. Yeah, we can do it again. Alright, why do you get an I as a root of a quadratic function? Right? So what is the root of the function? Alright, so that's when you solve for the root, this means when y equals 0, right? So you've got some like a x squared plus bx plus c equals 0, okay? And sometimes you're going to get stuff like if y equals 0, x equals, ai plus b, right? Or you could just get x equals ai, something like that. When do you get this sort of thing? When and why? Conceptually why? So like draw me a picture of when you would get this as an answer. And that's why you'll see why it makes sense. Because what we're solving is we're saying solve x for y equals 0, right? Now when do you get an imaginary root? Remember, I doesn't exist. I doesn't actually exist. It's not real. So draw a graph. Give me a graph. Draw a graph of when do you see this? When would you see, some either x equals ai or x equals ai plus b? Remember, these are the solutions to y equals 0. So it's like if I were to plug a point in, we would get ai 0. But this doesn't exist. So what would the graph look like, right? Try drawing it.
이라고요?
No. It makes sense because, okay, it's not real. There's no point where y equals 0. Okay? What is y equals 0? Where is y equals 0?
X line.
Yeah, this is y equals 0. We're solving for some point on this. This would be, ai 0, but this can't be existing because I doesn't exist. So what does the graph look like? He has, I can see on his paper the answer.
저처럼? 그런 거?
x가 적을 때를 구해보니. 응? 그러니까 x가 적을
Okay.
때
x가 허수
There is no point where y equals 0. There does not exist a point
알려줘.
on this line. No point on this line y equals 0. It cannot exist. Yeah.
배워본 건 아닌 것 같은데.
Yeah, that's a good example. Why? Because
There's no point?
yes, when you solve for y equals 0, there's no solution. Nothing. It's not real. Right? So if I were to solve, I take something like this. This is what he drew. I'm sorry if I see her.
Huh?
Never mind. So she drew this, right? This is a good example. Why? Because there's no point where y equals 0. So when we solve y equals 0, we get something that's not real, right? The solution is not real. Solution not real. Okay?
예.
Now, I want you to think about, if you look at the equation now, we did this last time, but if you look at the equation, when do you get this as the answer? And when do you get this? What are the conditions on A, B, and C? Right? So, okay, you have some quadratic formula, right? This might be helpful. This is solving for y equals 0, right? So y equals 0 equals ax squared plus bx plus c. Right, this solves for x. When is this the solution? So when do you get some function of I, right? When do you get something times I? When do you get ci? Where this is just a constant. What's the condition?
b
Is?
equals 0.
Yeah. Why?
Because b is just a real number.
Okay. So what is this equal to? This is minus b over 2a plus or minus the square root of b squared minus 4ac over 2a, right? What is this? Is this imaginary?
real number.
No, this is real. So, how do we get something that's only imaginary?
아, 그래서.
So b is 0, right? So b equals 0, we know b equals 0, and then what else do we know?
왜 했냐고.
Only imaginary number.
하지 않았어.
학교에서
아니 여기서 하지 않았어.
했어. 네
We did this here. We do again because people don't understand it.
미안해, 내가 이해력했다는
He didn't understand, so we do it again. That's good. If you don't understand, it's okay. Then we do it until you understand. Right, so b is 0. If it's purely imaginary, b is 0, right? Because there can't be a real part, which means that this needs to be 0, which only happens when b is 0, okay? Alright, now, what else do we know? It's imaginary. It's not real.
Yeah.
So, what does this need to be? This needs to be
Not true.
imaginary,
Yes.
which is true when?
True when b square minus 4ac is less
Well, this
than
is 0.
0. Yes. Minus 4ac less than 0.
Or 4ac greater than 0, right?
Yes.
So minus 4ac less than 0, or 4ac greater than 0, right? Because, you know, this needs to be the square root of a negative number for it to be imaginary. Okay. So, our two conditions for purely imaginary are what? B equals 0 and
4AC
for
greater than
A,
0.
C greater than 0, or in other words, A greater than 0, C greater than 0, or A less than 0 and C less than 0. Okay? Because that's the only way that you get this to be a positive number. Okay? So now give me an equation example where it has purely imaginary roots.
X equals 4.
Yeah. Why? So B equals 0. Right? No x term. Alright, A equals 1. C equals 4. Yep, they're both positive. Means that we're going to get some I as the root, right? Alright. Cool. So everyone's got this, right? Everyone knows why you get the imaginary number.
Yes.
It's okay now?
Yes.
Okay. Cool. The reason why you just solve for the I is because the thing is that they're, like these complex numbers, it's very inconvenient to have to deal with the square root of 1, which minus 1, which doesn't exist. So people just use I as like, you know, to mean that, so they don't have to keep writing the square root of minus 1. And it comes up a lot in like, you know, physics, and that kind of stuff. So they just teach it to you here because it especially comes up when finding roots.
When you use in the real life.
Only if you do like physics, maybe some you see in engineering, because you'll see some in differential equations. And then if you go into certain fields of math, like, you know, complex analysis, there's an entire course that basically revolves around complex numbers in the form AI plus B. But it's very difficult math, high level, very abstract, that kind of. I don't do it. I don't know it.
I'm humanity. I do my math.
No, you're good at math. Stop, you guys. Come on. Ugh. Okay. See, I think if they teach you this in school, it's actually much better than solving the equation, because this, you know what it looks like. You know when it is, you know, imaginary, why it's imaginary. Do they like draw this and explain in school?
Korean people all know that, then skip that process and solve different questions.
But you don't need to solve different questions. You just need to understand. You understand, you can solve all the questions. You know, they ask you what the graph looks like, you put points in. You just need to know, like, what it looks like. Okay. So, what did we do last time? We did graph inductions. I have a couple other problems that are similar. Maybe a little harder, but we need to go back to this one because it's pretty difficult to get this graph induction idea. Okay? So we did the coloring, right? And the degree. Okay. Alright, so we've got, like, you know, some graph. Oh god, why did I make these so big? Okay. Alright, I've got some graph, you know. Let's make it have a cycle. Alright. So this is our graph. Alright, how many vertices do we have?
6.
6 vertices. Alright, how many edges? what's the max degree of any vertex?
4.
Yeah. And that would be this one. Is connected to 4 others. Okay? Alright, cool. So, my claim is that any graph with n vertices with max degree D can be colored with D plus 1 colors, right? Alright, and so just remind you what coloring is. What is the condition on a valid coloring?
Maximum vertex.
2 vertices next to each other, can they have the same color?
No.
No. Alright, so let's see, let's color this graph. Alright, if I leave it blank, it's white, because it might be 4, I'm not sure. Alright, so I'm just going to go ahead and color this one red. So neither of these can be red. Oh, well, that means this one can be red. This one can't be red. This one can. Alright. Now, I've done all the red ones because everything. Next, I'm doing blue. Let's go ahead and make this one blue. Oops. Alright, well, blue is done. Alright, and these 2 can be black. And this would be a valid coloring. And this is a valid 3 coloring, right? Because we use 3 colors. Now, I did say that it's D plus 1. Here, D plus 1 equals 5. So it could be less than 5. It could be possible to color it with less than 5. That's okay. It's just never more than 5. Okay? Okay?
Yeah.
And so the key is that we're going to try to prove this by induction
Oh.
on the number of vertices in this case. Okay?
Yes.
Alright. So, how is this going to work?
What?
Let's start thinking. Let's start thinking why this might be true. So, you've got some vertex, right? Let's look at that vertex of max degree. There could be more than one, but let's look at a vertex of max degree. Okay? So, it's going to have, you know, a bunch of things it's connected to, right? And let's imagine that, you know, there's D of them. It's connected to D other vertices. Now, why? So let's draw some of them. Alright, so let's see what happens. So these all need to be a different color, right? Different color than this one. Alright, so our worst case scenario is what? Our worst case scenario is every vertex here is connected to every other vertex here, right? So then that would be the case where everything needs to be a different color from each other. This is terrible. Worst case scenario. Can't be worse than this, okay? So what do we have to do? Everything has to be different. How many vertices do we have? It's connected to D others. So how many vertices total? D plus 1. This is the 1. Okay? D plus 1 total. They all need to be different color. Okay? All need to be different color. How many colors do we need? So yeah, so in that case we would need D plus 1. Now my question is, why not more? that there are cases where we need at least d plus 1. There could be less, it could be d plus 1. Why not more?
Because it is D plus 1 vertices.
There could be more vertices. I could have a ton of other vertices out here. There's n. Blah. And they're connected here and there and blah blah blah. Anything. Okay? So why? So what does this mean? This means no vertex has degree greater than d. Okay? Why is that important? It's okay. This should take some time to think. Okay, what's the first thing you should do? It seems difficult. What should you do? You should draw. You should draw some examples. And I'm going to give you a hint and say, draw the worst case examples and see if it keeps working. Okay? So let's see what the worst case examples are. So for 1, it's just 1.
Yes.
Degree is 0.
Yes.
D plus 1 equals 1. One color. Alright, for 2, you need to have it like this, unless they're not connected. D?
Yes, 1,
D plus 1?
2.
Alright, now let's look at bad cases. Bad cases are when everything is connected to everything else. Okay? Alright, so this is n equals 1, n equals 2. Now let's look at n equals 3. Okay. Alright, this is bad. Bad case, okay? Everything connected to everything else. What's D?
D3.
No, D is 2. D is the max degree. This only has 2 connected to 2 others. Okay? Alright. Now, let's see. Can we 2-color this?
No.
No. We need 3 colors. Why? Let's make this one red. Can the other 2 be red?
No.
No, because they're connected to it. So, we make one of them blue. Can the last one be blue or red? No, because it's connected to the other 2. So we need 3. Do we need more? No, because there's only vertices. Okay, so what's D plus 1? It was D plus 1 colorable. 3. So we've never exceeded D plus 1 so far. Let's keep going. Okay? Let's keep going. And see what happens. Alright. I'm sorry. Alright, so now we've got 4. And again, we want to look at bad, hard to color it with a few colors, okay? So everything is connected to everything else. Alright. Everybody dated everyone. Okay. Stop. Okay.
트레디셔널 보드게임.
Oh, it is. I was thinking like matching, and I was like, okay. So basically, what is D?
3.
D equals 3. Okay. And can we? How many colors do we need? So n equals 4. D equals 3. How many colors do we need?
4.
Yeah, we need 4. But we don't, do we need more than 4 colors?
No.
Oh. Okay, so we can 4 color this. Now, let's just take this case of n equals 5. So, how many colors do we need? And how many colors do we need more than do we need more than D plus 1 colors, right? So D is still 3. Do we need more than 4 colors?
No.
No. Why?
Max degree is 3.
Yeah, so, alright, red. None of these can be red. But this one can be red. Right? And then the other 3 can be different colors. So, it's still D plus 1. It's still D plus 1. So we're seeing a pattern. We see that we don't need more than D plus 1 colors. Alright? And the nice thing about induction here is that we don't have to go and keep drawing every graph. We can say, okay, assume it's true for a bunch of things up to an end vertex graph. Look at the n plus 1 vertex graph of degree D, and then see what happens. Okay? Alright. Wakey, wakey. Wakey, wakey. 아이고, 자고 있어.
잘했어.
나도 오늘 아침 시험 봤어.
시험.
화학.
오.
과학이랑 그 수학 마크.
수학.
I had to, you know the kingdom problem? I had to present the whole proof and everything on it.
present.
아침에 왔더니
마음표.
오. In June.
힘들었어. Okay, so let's start working on our proof now. Okay, what is our inductive hypothesis?
Induction.
Yeah, so we're going to induct on what? What are we inducting on? What are we looking at? What is changing? So this is constant, right? So max degree is always D. Alright, so let's write that down. Alright, so that's number 1. Alright, what's number 2? 2 is number of edges doesn't matter. And 3, we want to show for all n, right? Which means we are inducting on n, which is the number of vertices. Okay? Alright, so max degree is always D. We're keeping that constant. It's just some constant D. Okay? The number of edges doesn't matter. It's not mentioned in the question. That means it doesn't matter. Okay? And we need to show for all n, which means that we're going to be inducting on n is the number of vertices. Okay? Alright, what's the inductive hypothesis? 괜찮아요?
The color is D plus 1.
That's an edge, yes. Okay, yes, just a reminder, this is just notation. This is edge, right? It connects 2 dots. And this is vertex, or you'll see it written node also. Sometimes it will be written, this means same thing, okay? Alright. So inductive hypothesis is what we have here, okay? For all n, an n vertex graph with max degree. It's always the same. What is it?
D.
Yes. Can be colored with what?
D plus 1.
D plus 1 colors. And if you're British, you write it like this.
Yes.
This is England.
Oh.
Also, you call. There are some different words.
미리는 오요.
Yeah.
미리를 한지도 오요.
아 그래?
Yeah. If you're. What is the base case? We did it.
equal 1.
Yes, we did the base case. Okay. N equals 1. We have one vertex. Okay. We can single color it. Right? Okay. Cool. Alright. Now we have the inductive step.
아 yes.
The best part. The best part.
I hate this.
아
No, you should love it.
No.
You should love it. This is the fun part. This is the part where you have to work out all the math.
I really love my family.
That's a good, what a good boy. You love your family. That's so nice.
Not that. I have no mind to love them.
Why? Why? It's so. Wait, it's like so cool though. Okay, think about it this way. Basically, I gave you something that seems like impossible to prove, right? You see a pattern, but you don't know if it's for sure, right? This tells you until infinity, forever, it's always true. It's like, and this is simple proof actually. This is not very difficult by, proof standards, right? So this is like a very like straightforward way of, it's like, you can prove anything basically. Well, not anything, but you can prove a lot of things as like something goes to infinity, right? The sum of the first n odd numbers is n squared, right? You can just prove it. Just prove it with your inductive step. It's very nice. It works out very nice, okay? Very nice. You should love it. It's much easier than writing out things in infinite number of things.
There is no way to prove another way. Not inductive.
You probably wouldn't want to do the other way because it would probably be much harder. That no one would do it because it's much harder. No one wants to do that. But also the thing is that this kind of proof, these graphs, especially graphs and like inductive proofs with graphs, this is like very central in any kind of computer science or algorithms course. So a lot of your, if you take an algorithms course, a lot of the algorithms that they'll introduce to you, the way that you prove the runtime will be some sort of graph argument. It might not use induction, but it will be kind of similar to like figuring out this degree stuff and splitting the graph into two pieces, deleting edges, pulling out vertices, like that kind of thing, where you have to make a proof argument. And that's, I think, actually a little harder than a simple graph induction proof. So we do this instead. When I try to prove, like in the algorithms course, I can confuse myself. Sometimes it's very confusing.
You're confused already.
Yes, I know, but when I first saw this, I was a little confused. Everybody was confused in the beginning. That's good. Confusion is good.
If they're not confused, they're a monster.
No, see, the thing is, the monsters who aren't confused is because they already learned it. So when you go to college and you take your algorithms course or you take your discrete math course, you see it and then you're the monster. The other kids are like, why is he not confused? Oh, because he's seen it before.
포켓몬스터, 피카츄.
Yeah, so you will be the monster in college that already knows it.
피카츄.
My brother used to love Pokemon cards.
포켓몬카드 좋아했대.
아 오빠 그
아.
어렸을 때 그 제가 어렸을 때는 되게 인기가 많아서 카드
In USA, it's
카드
Korea is too.
yeah he has like a whole collection of cards.
오.
I like that too. I like that.
얘도 집에 보면 포켓몬 카드 엄청 많아.
재미.
I have a
너무
Pokemon card in home.
Still?
When I was young.
Okay. Everyone, any ideas? So, what is usually our first step?
If n is 2. 아, 어춤을 먼저 해야 돼.
Yes, yes. Why?
네? Why?
So we showed the base case. And now what do we need to do? Show n implies n plus 1. Okay? If this is true, this implies this is true, then it's always true. Because the domino falls, the first domino falls, then all the other dominoes will fall. Okay? The dominoes will fall if the first domino falls. Okay? So base case and then n implies n plus 1.
Let me think.
Alright. What's the first step in any inductive step? Assume. We have to assume something.
Assume n is right.
Let's just call the inductive hypothesis P of n. Yes, assume P of n is true, you know, for
all n.
for an n node graph. No, it can't be all n because we need n plus 1. So it can't be to infinity. Okay, for an n node graph. Okay? So what have we done? So P of n, what is P of n? P of n is just this statement. Okay? It just means this. That's it. P of n equals this. It's just the hypothesis. Usually the notation is denoted P of n. That's why I wrote it. So you can see it and then you won't get confused if you see it later. Okay? So then it's easier here because you can just say P of n is true. Okay? Alright, then what do we do? What's the next thing that we do? What do we want to look at? We know it's true for n. So, what do we do now? Consider an n plus 1 node graph. I didn't use vertex, so I should say vertex. Sorry. Same thing. Vertex node, same thing. Alright, so how is this gonna look? We want to show that if the goal is to show if n node d plus 1 colorable then n plus 1 node also. Alright, so I want you to draw the n plus 1 node graph for some n plus 1 and some n. Okay? So I'm going to give you, like last time, I'm going to give you some numbers. And I want you,
You will give a max degree.
yeah, I'm going to give you d, because d can be anything, except what can d not be more than? What's the constraint on d, actually? This is a good question. So we know d less than or equal to what?
And
Almost.
n minus 4.
Yeah. Why?
Except itself.
Yeah. So we have only n nodes in the graph total, right?
Yes.
So, right. And we're not doing directed graphs. There's no self loops. So, it can only be connected to n minus 1 of things. There's nothing else it can connect to, which means the max degree of any vertex, it can't be more than n minus 1. Okay? Alright, cool. Alright. So now I'm going to give you a example, okay? So n equals 9, n plus 1 equals 10, d equals 5. And I want you to show that if this is 6 colorable, so show that if this is, look at the n plus 1 graph and say, we know that this is 10 color with 6 colors, right? Right?
Yes.
We can color this one with 6 colors by the hypothesis. We assumed it. Alright? Show you can color n plus 1 graph with 6. Okay? Okay?
Yes.
So start drawing your graph. This is quite difficult, so don't, but it's like very important, so I think it's good to.
Draw that.
Yeah, draw a graph. Your graphs are so weird.
I like weird.
What?
I like weird.
Me too. Normal is boring.
Last time we drew that. I drew that.
Yes. Okay. Max degree 5.
Yes.
Yes. Okay. How many nodes do you have?
10.
Good. Okay, take one out.
This out.
Okay. You know that this one is, how many colors do you need for this?
6.
Yeah. Well, not need, but you can do it with 6 colors. So then you put this back in.
It's in.
Yeah, because it's only connected to 2, you just make it one of the other 4 colors. Okay? That's how the proof is. That's it. It's just with n plus 1, okay?
일단 한개 빼야 되는데. 아무거.
힘들어요.
이거 끝났네?
So you can make any graph of 10, just make sure that no vertex connects to more than 5. Alright, yeah, you got one of degree 5.
거꾸로 돼 있고, 이렇게 거꾸로.
Yep, and then you make 10, right? So you have 10. You want n plus 1? 몇 개?
이거 보기로 안 돼.
10개.
보기로 안 돼.
이제 어떡해.
그냥 연결해.
다?
아니, 다 아니고 그냥
근데
뭐 코로나
그럼 나머지
이거
그냥
한 점만 다섯 개가 됐어. 나머지는 어떻게? 아무
한 이상. 한
그
이상. 가성비 이상 다섯.
한 개 얘가 다섯 개.
키우는 단어가 일본어
왜냐면
그다음 영어는
틀려서 얘만 다섯 개야.
그게 쓸 수 있어.
정말이다. 서울 단어 준비하냐?
난 일본어 배우고
맥스나 한 점에서 최고.
일본어 습관을 모르고 짱구로
졸려 죽겠다.
히스패닉 원어
어떻게 하는 거야?
히스패닉 원어 나는
이제 마음대로 인데.
난 싫어 왜 일본 중국 웅성한 거
계속
좋은 사람
그냥 더 이상 이게 뭐야?
맞아 아이가 정말 안
여기서
몇 개 전.
분명히 모르잖아.
그거를 자꾸 상황 안 하고
아니
다 물어보는 게 그렇게 하는데
보이십니까?
빨판으로 있어. 빨판으로.
He hates China.
Why?
because they're rude.
You would fit in it. You're gonna make it inappropriate. Nope. It's like you would fit in with some people in America.
They're Chinese American. I hate just Chinese.
I mean there's some American, not Chinese American, but there's some American who hate just Chinese, which is bad.
Like Trump.
Like Trump, yes.
He despises
China.
얘를 빼면 다섯 개 얘기했는데 사라지잖아. 그래도
그냥 싫어.
칠할 수 있기 때문에 가능하다.
You just heard it. No, there's Chinese American is fine.
Yes.
They're American.
But just Chinese is nothing. Character is nothing.
이거는 그것 때문에
이걸 뺐어. 근데 글씨가 없어.
좋을 수 있어.
I like Japan than China.
You're not popular in Korea. Korea is opposite of you.
좋은나무교회 사칭.
But I think 일제강점기 didn't exist. Korean people may not hate Japanese because
Yeah.
the historical.
They hate because history.
And their trade problem.
Oh,
그냥 디그레드 샵도
Do you know?
똑똑.
I know, yes. Japanese people is crook.
I mean, yeah. I mean, everybody is correct. Trading.
I have a question. Do you think Dokdo is a Korean?
I don't know. So I say, okay, Korea says it's Korean, okay.
그러겠지.
They say they found lots of Hangul or Korean stuff on it. So I
It
guess,
is written much before the Japanese.
Yeah. So I guess I think it's Korean. I don't know enough though. 그냥 켜볼게.
나도 몰라. 이렇게 쓰고 그렇게.
Okay. So we have a 10-note graph. Okay. Alright, now, what do we know? What do we know about, we know we can 5-color a 9-note graph. So what are we going to do? I'm going to pick a random vertex and take it out. And then I make it 9.
Yes.
This all can go away. Hooray! Okay, now I know that I can 9-color this. Okay? So let's 9-color it.
Nine color.
I mean, sorry, 6-color. C1, C2. Let's make this C3. Actually, this can be C1. Okay. But let's let's just use 6 because that's what we want to do. C3, C4, C5, C2, C6, C1. Okay, I put some random colors on them. What do these C's mean? These are just the colors. Okay, C1 is color 1. Okay? Now what do I do? What do I need to do now? Well, I 6 colored it for the 9-node graph. So what do? I want to see if it works for my 10-node graph. So, you know this guy who came out? We're just going to put him back in. Okay? We're going to put him back in. And then we get these connected. Woo. Okay. Now, tell me why this graph is still 6 colorable.
Because the only 5 maximum
Yeah.
degree.
So, this one, how many was it connected to? Maximum. 5 max.
Ooh.
5 max neighbors. Alright,
Yeah.
now, even if they are all different colors,
Different color.
so let's see. Let's make this C3, okay? So that they're all different. No, we need to make this C5. Yes, C5. Okay, so here we've got C3. We have C1. Alright, connected here we have C5. Okay?
Yes.
What's here? C6
C7.
and C4. Alright, so what's out? We can't use C1, C5, C3, C4, C6, which, since there's only 5 of these and we have a 6th color, what is our 6th color? It's C2. This is the 6th one. We make this one C2. And it works. Because it can only be connected to a maximum of 5 others. Alright. So now we want to try to generalize this to any n. Okay? Any n. So I want you to just tell me, make an argument similar to this. Very similar. Okay? Just use random n. Sorry, this is an R. Okay? And n plus 1. Alright. Okay. So, what does this say? This says that n vertex graph is d plus 1 colorable. Okay? So what are we going to do now? We do exactly what we did with this.
N plus 1.
I just want you to put it in terms of n plus 1 and n. Okay? Try. I know it's hard. It's hard. It should be hard. Any ideas? Ideas.
Good idea is good.
It can be a bad idea, that's okay too.
Any idea?
If you're wrong, it's fine. If you're wrong, it's good.
Yes.
Then other students can see why you're wrong and you all learn more. I expect you to be wrong. I don't expect you to do this correct. Okay?
Like that?
Yeah, it's exactly like this. Exactly the same, just with n plus 1 again. So what did we say here? We said n is 9, n plus 1 is 10, d is 5. Now, instead of this, just imagine that these numbers don't exist and make exactly the same argument. But there's just no numbers on it. It's just variables. But it's the same, exactly the same as this. This is essentially your proof. This is your proof, basically. This is what you need to do. It's just no numbers. This is, your numbers are d, n, and n plus 1. You don't know what they are. You just know that they are some number. His face is like,
Me?
his face is, he's so smiley. It's funny.
Oh.
I have an idea. We have to ask for Siri.
What? What?
Siri is bad.
Siri
Bixby is better.
foolish.
Galaxy is better.
No.
Siri is foolish. He can tell me an answer. Draw the picture.
So yeah, I want to, well, you don't need to draw a picture. I want you to explain to me. You can draw a picture, but just, it would have to look something like, you know, it would be like some nodes and then, you know, you'd have some, this one would be like connected to the others,
Yeah.
right? So this has degrees. Okay? And then you have n nodes. N plus 1, I guess you could say n plus 1 nodes. And what are you going to do?
D plus 1 color.
Well, you want to show that, but what are you going to do? So you have some n plus, we know that the n in any n node graph with vertex of no more than degree d is d plus 1 colorable, okay?
Yeah.
I'm giving you a random n plus 1 node graph that has a vertex of degree d. We're saying this is connected to d others. What do I do now? I need to make it,
Something else.
yeah, I need to make it an n node graph because I know that for an n node graph, I can color it. So what do? I have to get rid of one. I have too many, okay? Let's pull out a random one. You know, it could be connected to anything between degree, so 0 less than or equal to degree less than or equal to d, right?
Yes.
Because the degree is somewhere between 0 and d. It could be d, it could be 0, it could be 1, you know, it could be any of those things, okay? Alright, cool. So, then what do? I take it out. Alright, this one goes bye-bye. Now, what do? I have an n node graph.
Yeah.
So,
I know can be called the T plus 1.
I color it with d plus 1 colors,
Yes.
which I can do because
There's D nodes. D degree.
we assumed it.
Yes.
The max degree is d.
Yes.
The max degree is d. We assumed that if we have an n node graph with max degree d, we need d plus 1 colors, maximum,
Yeah.
okay?
Yes.
So we color it. Now what do?
Put it back.
Yes, we take our node and we put it back in. Now we've got our n plus 1 node graph. So what do? We connect it to all the things it was connected to. Now tell me why this graph is still d plus 1 colorable. Why? Because this one that we took out, this is the max degree. Can't be more than that. So,
D plus one color.
yeah. Because even if all the D that it's connected to are named colors C1, C2, CD, right? So even if they're all different colors that it was connected to, just like here, we can use CD plus 1 to color the N plus 1 vertex that was removed. Okay, sweet. Now, that's the end of the term. That's it. But there's one thing I need to ask you, and that's saying, why can't I just take an end node graph and stick on an extra vertex to make an n plus 1 node graph? Why do I need to start with an n plus 1 node graph? Why do I have to take it out and then put it back in? Why couldn't I just look at the end node graph and then put it in? Why is that bad? This is very difficult to understand, but I want you to think about it. Because when they give an exam in this course, and they give a question like this on the exam, a lot of kids, they mess that up in MIT. So college kids, they mess this up. Why can't you start with n and then add 1? Why do you have to start with n plus 1, take out, and then add back? Any ideas?
If you start n nodes and you plus add it in, that can be the new one can be more maximum degree.
That's the first problem. The first problem is that it could be max degree d plus 1. Now the second problem is, assume it's not. So assume that you've designed it so that you add something that's only connected to one other vertex in the previous graph. Why is that bad? So the key is that we need to show for any n plus 1 node graph, any possible graph. Now, the problem is that there are some n plus 1 node graphs that could not be constructed by adding one node to a given n node graph. So if I take some graph that has n nodes, right? It's a very specific graph. You know, it could be very different from another graph that has, imagine if, n equals, so imagine if n equals 4, d equals 3, right? So we could have something like, or I guess I'll put, I kind of want to do d equals 5 because this is a fun graph. Okay. So imagine we could have something like this, right? Or sorry, not n equals 4. Let's do n equals 6. Alright, let's do that one. Alright. I could have something like that. Now, what could I also have? I could have something where everything is connected to everything else. Okay? Now, these two graphs are very different, right? Yeah. These two, nothing alike. Nothing alike. Now, if I start with this one, can I make this graph?
No.
No. Very bad. Okay? Now, if I start with this one, can I make this graph?
No.
No. And that's why you cannot start with n. Because you need to show for any n plus 1 graph. So it would be fine to start with this n plus 1 graph and then say, here's my n graph. Alright, now this n plus 1 graph is possible. You could do the same for this one. You could say, here's my n plus 1, let me take it out. Here's my n. And then add it back in. That's okay. Okay? Very common mistake to start with the n and then realize that, you know, you've messed up. Very common. A lot of students, they do that, sadly. Okay. Cool.
싸대기 때려 싸대기.
Everybody sort of, okay, you understand a little bit, right? Little bit.
조금이라도.
That's okay. That's good. You've seen it.
아예 안
You've seen it, okay? Now if you see later, it will be easier. Okay. Okay, now we do another problem that I have. Unless, because there's some stuff I want to teach before next week. So we can either do another graph problem or we can switch gears to, you know, we did probability, right?
Probability.
So we did probability,
Yes.
right? Okay, so I kind of wanted to do another graph problem, but because we have a visitor in a week,
아 visitor.
in a week we have visitor.
Next week.
Next week,
Next week.
yes, we have a
Who
special
is it?
visitor. I don't tell you.
Foreigner. Or
I don't know. I don't tell you. Okay, so we need to cover some things before that.
Next week?
We have to do better.
No, we need to learn, okay, before next week on Saturday,
Yeah.
we need to learn expected value, which has to do with probability, right?
Yes.
So we can either do that or we can do more graph problems and leave less time for probability, expected value, random variables.
I'm very wonder who
Do you know
he or she, girl or man.
random variable?
Only the I answer.
That is a random variable, whether the baby is a girl or a boy. You could call that a random variable. Okay, so what do you want to do?
No.
You want to spend more time on probability or on graph?
Probably. It'll be easier thing.
It's much easier. This is harder.
Probably.
This is harder, in my opinion. Well, most kids in the class think that this is harder. In college class, they think it's harder. That's pretty hard, but I kind of wanted you to see it, because it's cool. Okay, so, remember that we have, you know, we can write probability like as some sort of event, right? So if you imagine that, oh, some good ones, there's some good ones, okay. Cool. So I got my, this is called a sample space, right? Okay, this is just the name of it. It's just the name, it's just the name, okay? Don't worry about it, it's just what they call it. Alright, so, imagine that, you know, you have a coin, right? Does anyone have money? Can I have your money? Give me money.
돈이 없고 카드만.
I'm joking. No, coin. Like coin.
야, 누가 도전을 들고 다녀? 보여줘. 동전이 있어? 진짜. 나 없어. 다 버스 정류장에다 떨어뜨리고 그냥 버려.
네, 풀 때.
그럼 펭귄. 아 진짜.
일수건
왜 학습증이야? 그다 봤어.
누가 했어?
뭐야?
Because she or she will is.
펜수 없지
I
있어.
was no,
그 여기다 갖다 대면
You're only ashamed because of Korea.
자기
Because
여기다
Korea is
펜수를
so-
하고 있어.
유명한 트레디션.
Why do you care so much
아
about
충분히 자신 있으니까.
people's face? Other people's faces.
그래? 이따 한번 보자. She says that she is confident of her face. So
아니야.
see her ID card at her class.
Yes,
너
I saw
나가볼
it.
거야.
어?
Yeah, I saw her ID card.
우와.
Yay, money.
500원이에요.
내고는
아 500원 다 떠내기.
콩크리트.
드려야지.
I'm joking. Okay.
진짜.
$100.
Okay. This face. Okay. This is called heads. Okay. Face.
Do you know who he is? In
세종.
no,
세종대 뭐니?
제너럴리.
generally.
누구?
나는 로버트 리.
I know. Face equals heads. Okay.
Yes.
Well, do you know what that means?
그림.
It's a head. It's a head. It's a head. Okay, and for some reason, the number.
Okay.
Yeah.
나 원 플러스 원이라고 봤어. H 원 플러스 원.
All right. All right. So we have in our sample space, we have outcomes.
악형이.
아웃.
이름이.
What are those? That's just like I flipped it and I got a heads. Then that would be an outcome. So if I flip, let's say I flip it 3 times. What are possible outcomes?
8.
Yeah, 8 possible outcomes. That's right. What are they?
Or head.
Yes. H, H, H. Right? Head, head, head. I flip. I got heads 3 times. T, T, T.
T H T T T H T T H
2-3 times. Galaxy set.
H T H
그치.
T H T
아니야? 괜찮아. 그거 아니야?
T H
아.
H
Any more?
No.
No, there's only 8. Why?
몰라요.
Oh, come on. You know why. Why? I flipped 3 times. Okay, first, second, third.
4.
No. How many options? I can have head or tails. Head or tails.
해탈.
Head or tails. Okay. So how many options total? So we have 2, 2, 2.
8.
8
오늘 천재야.
Yes.
2
Is 4. 2 plus 2 is 4.
2, 2, 2.
2, 2, 2.
네.
2 times 2 times 2 is 8.
네.
Yes. Okay. Now here are our possible outcomes. These are going to go into the sample space. The sample space consists of outcomes. Okay? That's all possible outcomes. So in here we would see some, H, 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 T, 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 H, H, etc. All of them will be in here. Okay? Alright. So basically what happens is I can define something called a random variable very, very. 맞아요.
very very strawberry rescue.
살짝 부어버리자.
왜 이래?
안 궁금해.
Boomer.
우리 수학쌤 생각나.
Okay, random variable. And what is that? That's just something that, you know, it represents an event. Okay? Represents outcome or group of outcomes. Oh, I missed the C, sorry. Represents an outcome or group of outcomes, right? So I could say let X equal the event that I get 2 heads.
Well, I means letter I or this.
I. Capital I. Capital means me.
Yeah.
So X is the event that I get 2 I's. You could write P of X equals probability that X occurs. Okay?
Yeah.
And what is that?
3/8.
Yeah. Well, yeah, it's 3/8. If I said at least, it would be, right? Because which ones do we have 2? Here's 2, here's 2, here's 2. The rest of them, they don't have only 2, okay? Alright?
Yeah.
Alright, so that's a random variable. You've just defined something. Okay?
Yes.
I could also say, let X equal, 0. So you say 0. Usually when it has 2 values, you draw this squiggly thing on the side. 0 if I get at least 2 heads. 1 else. Alright. So, this is another X. I've defined it such that if I get at least 2 heads, then X equals 0. If I don't get at least 2 heads, then X equals 1.
Otherwise, the shape.
So when you say something has 2 values, like if X equals A or B, it usually, you draw it like this. It could be like, or you could have it like A, B, or C, you know? And then you have condition, you know, sometimes it's this, sometimes it's this, sometimes it's this. Okay? Cool?
또 이거
At least 1?
At least 2
I
heads.
couldn't.
Alright, so this is what's called an indicator variable. And what that means is it only takes on values of 0 and 1. Okay? So it can only be 0 or it can only be 1. Okay? Can't be anything else. Only 0 or 1. It's binary. It's a binary variable. Okay? Alright. So then we could say something like P that X equals 0 equals what? The probability
Then
that X equals 0 is what?
I'll get 3 headed.
At least 2 heads. 이상.
그 구분의 3이 들어가네. 8분의 2분의 2 하나
At least.
at least
Px equals 0 if I get at least 2 heads.
Teacher, what is indicator?
That's just something that only takes value 0 or 1. Indicator variable. It's just the name. It's just the name. So if it can only be 0 or 1, nothing else, you just call it this name. You don't need to know. I just said because you might see it and then be like, what's that? You know?
X is 0 means
one hill.
Indicator, it means that it can be 0 or 1, but it cannot be anything else. It can't be 2, can't be 1/2, not 3, only 0 or 1. Binary.
what is 1 mean?
1 mean else, so else means that I don't get at least 2 heads. Okay? So I do or I don't.
X equals 0, 1/2?
이 이상까지는 그 앞면에
Yeah, px, yeah.
그럼 두개 이상
맞네.
여기까지 오죠.
Why?
그러니까
그래서 두개 이상 가지는
Pieces.
Why?
two eights with 3 and 3 eighths including because at least 2 eighths.
Yeah. Alright, so everybody, p of x equals 0 is 1/2, right?
Yeah.
There's 4 cases that work, 8 total. 8 in our sample space, 4 of them are good. And then px equals 1.
1/2?
It's the or not case, 0 or 1. Alright, so now instead of probability, we're gonna sort of introduce a concept that might be a little bit difficult to think of at first, okay? So, I'm gonna So, first, let's just take this x because it's very simple, right? So this is just, it can be 0 or 1, right? 0 if I get greater than or equal to 2 heads, 1 else. So we can write something, p of x, here, give me 1 sec, equals the expected value of x. Okay. And what is this? This would be this would be the sum. Hold on. Okay. Let's start simple. Alright, so we want to figure out what is the value, what is my expected value of x, right? So what do I have? I have 2 options for x, right? What are my 2 options?
0 or 1.
X equals 0 or x equals 1. Okay? So we figured out what p of x equals 0 is, right? So we have some probability. This event occurs with some probability. What's the probability with which this occurs?
1/2.
Yeah, it happens a half of the time. X is 0, right? We saw that. Alright, what's p of x equals 1? Okay. So, what is the value of x here?
0 and 1.
So I want to predict, on average,
Yeah.
what number am I going to get on average? So what do I do here? I write the expected value expected value, you know, the value that you think you're going to get if you had to predict, right? So E of x equals P of x equals 0 times 0. Because, okay, so the probability that you get this value times the value. Okay? I get this value this amount of the time. And I get, hold on, times 1. I get this value this amount of the time. Some fraction of the time I get 0. Some fraction of the time I get 1. This equals 1/2 times 0 plus 1/2 times 1, which equals 1/2. So basically, say I play this game, right? And I roll the thing 3 times. And I win if x is 1, and I lose if x is 0. Okay? If I say I get, you know, $1 million. I get $1 million.
Oh.
That's a lot of money. In one is this.
Oh.
Okay? A lot of money.
You can buy a house.
Yeah. You can buy a house probably in Gangnam. Okay. So if I win, I get this. If I lose, I get nothing. I stay same. Okay? So what's my expected value if I play the game?
1/2.
How much money do I think I should make? How much money do I make if I play this game? This is the case for x equals 1, x equals 0. Or we could write it as this is x equals 1, you know, x equals that, x equals this. Now, we've redefined it, right? Same conditions. If they get greater than 2 heads, I get nothing. If they get less than 2 heads, I get $1 million. I'm very happy. What is my expected amount of money I make? Yeah, because when I play this game, right? So I play the game, 1/2 of the time I get 0. 1/2 of the time I make no money. And then 1/2 of the time I get $1 million. Equals $500,000. Not 5 million. I wish. Okay, $500,000. So that is my expected amount of money that I would make. So should I play this game?
Yes.
Yes, it's a good game. It's a very good game. Very good game. My expected value is very high. Okay? Now, alright. Let's look at another random variable that's not as simple and is not an indicator variable. So, what should I do? Alright. Let x equals the number of heads. I flip it, let's say I flip it 4 times. So, how many outcomes in the sample space?
16.
16 outcomes, right? If I flip it 4 times, how many possible outcomes? Yep. Got it? Okay. Alright, that's 16 possible outcomes. X will just be the number of heads. Okay? It could be 1 if I have 1 head. If I have 2 heads, what is it? 2. Right? If I have 0, it's 0. Okay? So what can I write it as? I can write P x equals 0 equals. What's the probability I get no heads?
No hands. 1. I don't know hands.
I always get no heads. If the probability is 1, it means every single time I never get a heads. It must be a very unfair coin. Very unfair.
1 divided 16.
Yes. Good. Okay. Now let's see P of x equals 1.
15 divided. No. 6.
Okay. So let's see. I have 16, right? Now, how many ways can I label one of them a heads?
3.
Why? It's 4, choose. Oh no, it's not. It's 3. It's 4, sorry. Right? Because, okay, it's like I have some sequence, right? I have some sequence where I have like heads, tails, tails, tails. Now, I can move this here, I can move this here, I can move this here. So, there's 4, choose 1, for where the heads goes, ways to arrange. So, what do I get? What's the probability?
1/4.
Yeah, 4 over 16 equals 1/4. Okay?
Wow.
There's 4 of these, 16 total.
Did you x equal 1 then one head? X equal P of
1
x
heads.
equal
Yeah, it's a probability of 1 heads because x is the number of heads. That means I got 1 if x equals 1. Okay? What's P of x equals 2?
1/4. 2.
How many ways can I arrange this?
4 choose 2. 6.
And how many total? Because I arrange this. This is 4 factorial divided by 2 factorial. 2 factorial. Permutations.
3 divide 8.
Yeah. So 6 out of 16 total. 3/8. Alright, what about P of x equals 3? This should be easy, now that you've done one of these cases previously.
Same. 1/4 is.
Yeah. Because instead you just got heads, 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 tails, and then this one, you just arrange them 4 ways. Okay? And P of x equals 4. They're all heads. 1 out of 16.
Yeah.
Alright, so we've written out a sequence of probabilities. These are all the possible values of x. So, the possible values of x are 0, 1, 2, 3, 4. Okay. Now, I want you to tell me the expected number of heads. Or I guess I'll just write h's, sorry to be easier. The expected number of h's. How many on average, if I were to flip this coin like a million times, and like, I do a million sets of 4 flips, on average, how many heads do I get? This should be very helpful to you.
Wait a second.
So, the expected number of heads, it's like telling you to compute E of x. So remember what we did there?
Well, 2.
I because it could be kind of messy. Alright, so when do I get 0 heads? How much of the time?
0 time
1/16.
1/16. Yes.
So 1/16 of the time I get nothing. Plus,
Why we have to times 0?
because 1/16 of the time I get 0. So 1/16 times 0 would be my value for that amount of time.
What value means?
Value is like, imagine that the number of heads is the amount of money that you get. And it's like you're getting some kind of value, right? So there's like some number of heads that is telling you a certain kind of, just, that is the value that you're looking for, is the number of heads, right? And so you want to say, if I play this game, how many heads do I expect to get? Like, what would I expect before playing the game? Should I play the game? It's a very difficult concept, so this can be a little confusing. It's sort of like, you know, when you're gambling.
Gamble?
No, that's not a good example.
Oh.
I shouldn't.
Powerland.
Okay, so this is usually where this comes in, like, handy, right? Because, you know, in America we have like Las Vegas, right?
Yes.
And there's a lot of gambling there. So, and it's legal, it's okay. You can go to a casino and gamble. So usually if you're playing like a game like, you know, poker or something, and you put money in, and you want to know how much money do I expect to get out, right? So I need to calculate, okay, here's what's in my hand, here's what I have, how does that compare to other people? You know, I win this probability of the time. You know, this probability of the time, I will win this amount of money. This probability, I win this amount of money. You know, sometimes I lose money, so I could have, you know, x equals -10 with probability 1/2, and that would make it worse. So it's basically trying to see, like, how much do I get out of it, right? So the practical application of this kind of, you know, math, like expected values and probability, is usually, a lot of it is with gambling or, like, you know, stocks, right? So you know how people invest in stocks?
Yes.
I don't know how to say it correctly. Stocks?
주식.
Cool. So people, they put money in, right? They invest. They should only invest if they expect to get money back. Okay? So it's like, think about it as like, you are going to play a game, and you have a list of outcomes that could happen. They happen with some probability. Now, if outcome A happens, that's good for you. If B happens, it's bad. So you want to say, do I expect things overall to be good or overall to be bad? Do I expect to make money or lose money? Do I expect to get value or lose value? That's usually how it would be used. So value is just this kind of thing that we're defining, where we can just say any values, basically. We could say x only takes on values 0 and 1. Maybe 1 is winning, 0 is losing. Right? You know, if I lose, say I'm playing, you know, a tennis match. If I win, it's 1, and I get some amount of money. If I lose, it's 0, and I get no money. So actually in women's tennis, like, I've played some like tournaments, you get money even if you lose in women's tennis. In men's, no.
Men's
Oh, really?
Men's, they're mean. The ATP is mean. The WTA is nice. So yeah, I would go, like, if you even go to like some international, like, sort of pro but not like WTA, like I've been, and you go and you literally like I lost in the first round, but I made past qualifier, but I lost in the first round, and I got like, you know, like maybe $100 something, $150
$100?
more for losing.
Oh.
No, it's okay. The girl was really good. She was like ranked on W2. She was like 600 something in the world. So I don't feel bad, but
Why didn't you participate in that?
cause I'm not good enough. She's better than me. That's okay. There are people better. It's very hard to be like, you can be good, but it's very hard to be like, you know, the best. Or in, you know, in tennis, like you don't make money unless you're like top 200 in the world. 200 best in the world.
Oh.
I'm not. I know I'm not. It's okay. So it's not. It's just fun. You know.
Tennis player earn a lot of money.
Only if you're very good. Actually, it's a problem, especially in men's
Novak
tennis.
조코비치,
He has a lot of money.
페데러,
He has a lot of money. Lot of money.
라파엘
라파엘
나달,
Lot of money.
또한 상관.
They all have a
정연.
lot of money.
정연 Korean
He
player.
probably has some money, but not a lot actually.
저 그때 발도 쳐가지고 기권 하잖아.
You'd be surprised at how little money they have, even if they're just down, not top 50. It's
Who
bad.
is the best tennis player in women?
Right now,
Yes.
Naomi Osaka.
Huh?
오,
Japan?
She's Japanese, but she grew up in America since like 2 years old. So,
Oh wow.
Japanese American.
Almost
so
American.
but she plays for Japan because
Oh.
like she's born in Japan.
She can speak English.
She speaks English and Japanese.
in Japanese 약간 약간 말 섞어.
그 교포 같은 거.
우리 같이 미국
Okay. So yeah, it's value. It's like expected returns. Okay. I put something in. I play the game. What do I get? Okay. Now I want to know what's my value of heads. How many heads do I expect to get? Okay. Say I'm making money depending on the number of heads. Okay. If there's 2 heads, I get $2. Okay. So I want there to be more. All right. So plus.
Plus
Well, I know that 1/4 of the time. 1/4 of the time, I get 1 head.
Yes.
Plus.
2, 3, 8, 3 over 8.
Yeah. So 3/8 of the time,
And times 2.
I get 2 heads.
Yes.
Plus.
1/4
Yes. So 1/4 of the time,
times 3.
I get 3 heads.
Yes.
All right. And what's my last one?
16.
1/6 of the team, I get 4, and I really win. I win a lot. I hit the jackpot.
Alright.
Equals 0 plus 1/4 plus 3/4 plus
3
3/4
plus 1/4.
1/4. Sorry, this is.
And yes, right.
1/4. Yeah. Plus
1/4. 2.
So I expect to get 2 heads. That makes sense. You know, it would make sense that, you know, if I'm flipping it 4 times, probability is a half, they're independent. I expect to get 2, right? 2 and 2 is most common. Yes, easy. All right, now I'm going to define the expected value. Okay. Because we need to have a sum, because sometimes there's a lot of outcomes. It's not just, you know, there's a few outcomes there. Sometimes we have so many outcomes that we just don't want to deal with it, okay? So, we define E of x, where x is a random variable, which we'll put RB, equals the sum,
Your R is RB.
random variable. No, it's not the truck thing. RV, random variable. Okay? The sum from I equals 1, so we have n outcomes. X can take on n values. So x takes on n values. 1 to n of p of x equals I, which will sometimes denote p of I, right? P of I times what?
1 to I. Times I.
I is the value, right?
저희 그건 아니지.
So it could be, I mean, it could be 0. You know, it's like if x takes on some value, right? So it's like for 0 less than or equal.
I is 0.
Could be 0. In this case, it was 0. Right? It was 0 because x could be 0. So x is in some range, right? Could be 1, could be 2. It depends on what x takes on, right? So in this case, it would be, say, if I said I flipped the coin, you know, 100 times.
오.
You don't have to actually solve this, but say x is the same as before. What is e of x in the sum?
Oh my god.
So what would it be? It would be the sum.
Wow.
So I have the expected number of heads. How many? So where does my value x range from, right? So I could have 0 heads, right?
So, yeah.
Less than or equal to x, less than or equal to
100.
100. Right? This is probability 1 over 2 to the 100. Okay? Very low. But so what does this look like? What is the expected value?
That looks like some.
Well, I want 1 over 2 to the 100. The probability that x equals 0 times 0. Probability that x equals 100 times 100. Probability that all of them, right? So, I'm going to have some sum from I equals what? What's the smallest value?
0.
0, yeah. X, smallest value of x is 0. What's the biggest? 100 of p of x equals I times,
오.
and you can just write it like that. Now, yeah, we should stop. But if x is an indicator variable, then what is e of x? So if x 0, 1, p of 0, p of 1 is the probability. What's e of x?
1/2.
No. This could be like, you know, 99 over 100, and this could be 1 over 100. E of x
is 0 times p of 0.
E of x is just p of 1.
Yeah.
Mm.
Yes.
Because this one goes away, and the only other option is 1.
Yeah.
Since it's times 1, it's the same value. Okay?
Alright.
Cool. We do more of this.
So you invest in stock?
Don't do that yet. My brother did some.
American stock?
Yeah.
Teacher finish?
Yeah. Oh, whose money?
Me.
No. Hey.
Stop.